right, hello again, my lovelies. We are on to day 2 of inverses of a square matrix. We are actually going to solve equations finally. So first thing we need to do is just practice writing systems of equations in matrix form. So that's example 1 right here. Notice the coefficients of the variables go into our A matrix. The variables themselves are the X matrix, and then the constants become our B matrix. Please do not change the order of the coefficients. That's very important to leave them the way they are. And example B is just a 3 by 3, so we have 3 rows and 3 columns, which you won't be solving at this point in time. When we come back after our lovely break, then hopefully we'll be able to show you how to do this into the calculator, but we can at least practice writing them into the equation format. So again, all the coefficients, since there is no z in the third equation, notice we do have to put in a 0. The variables become the XYZ matrix, and the constants become the B matrix. So now we're going to use inverse matrices to solve these, and we're going to use what we learned yesterday about the fact that if you multiply a matrix times its inverse, you get the identity matrix. So if we want to solve this equation, we would multiply both sides by its inverse, because A inverse times A would basically just disappear, so we'd be left with our variable matrix equals A inverse times B. Please remember, matrix multiplication is not commutative. A inverse times B does not equal B times A inverse. So we will be doing this one. We will be doing A inverse times B. So on to example 2. We're going to use inverse matrices to solve each system. So step 1 is to just write them as a matrix equation. Then step 2 is to find A inverse. And then step 3 is to actually do A inverse times B. And as always, we are solving a system of equations, so we write our solution as a point. So you can see right here, I put my coefficients into my A matrix, my variables into my X matrix, and my constants into my B matrix. To find the determinant, remember from yesterday, down diagonal times the up diagonal, so we get 1. The inverse is 1 over the determinant, and then remember the down diagonal we flip-flop, the up diagonal we change signs. So, well, 1 over 1 is just 1, so we just get A inverse equals -3, 2, -2, 1. So to solve our equation, we now do A inverse times B. So remember our multiplication, across row 1, down column 1 gives us 0 plus 2. Across row 2, down column 1 gives us 0 plus 6, gives us 0 plus 3. So we end up with 6, 3. So our solution is the point 6, 3. So let's take a look at the second example here. Again, first step is to write the matrix equation. So coefficients go in matrix A, the variables go in matrix X, and the constants go in matrix B. So then we want to find A inverse, so we start with the determinant, down diagonal minus the up diagonal, which again gave us a 1. I should have found one that gave us something else, but oh well. So A inverse, 1 over the determinant, and then remember, switch the down diagonal, change the signs on the up diagonal, and we end up with 7, -2, -3, 1. So to solve, we multiply A inverse times B. So again, dot product, first row times first column gives us the 7 plus 8. Second row times first column gives us a -3 plus -4. So we end up with a solution of 15, -7. And that's it for today, folks. So, missed you all. See you soon.